Good morning. Welcome to week 22 with Mrs. Bibb, Algebra 1 Honors. This week we're going to learn how to factor a polynomial. Please make sure to fill in your table of contents. Make sure to complete your weekly warm-up. There is a Monday. It's in the PDF. And we will go to the notes. I can't believe I don't actually have the definition written down somewhere for factoring, but it's really quite simple. The factors of 6 are 1 times 6 and 2 times 3. The factors of 12 are 1 times 12, 2 times 6, 3 times 4. So if you're going to factor a trinomial, you want to know what polynomials you multiply to get a particular trinomial. So when we look at this number 1, let's write the definition first. Let me write it up here. And if you will write it as well, we're going to write factor. And the best way to say factor for polynomials or trinomials is to undo the distributive property. Those of you who like FOIL could actually say undo FOIL, but I don't care for that. So undo the distributive property. There are many ways to factor, and this first way that I'm going to show you, I want us to do for now. Many students think it's okay just to use Photomath and you screenshot the question and then copy down what Photomath says the answer is. This is such an abstract concept that it's so important that you actually learn how to factor the polynomials. So I'm going to start with what I have found to be the easiest way. What we're going to do is we are going to make a table. Much like the table, and you all know I'm not the best artist, but much like the table that you made when you multiplied two binomials. In that table, the first term, let me grab a highlighter, the first term will go in the first box, and the second term, the last term will go in the last box. That's what we'll do first. So c squared will go in the first box, and 7 will go in the last box. Now, we know that the sum of these two boxes, when I add them together, these two boxes must equal this sum. What we're looking for here is we are looking for what goes, I'm trying to find a highlighter again, so I apologize. Blue. We're looking for what goes here and what goes here. That's actually our answer. Okay. How do we get c squared? C times c is c squared. How do we get 7? What goes in the green box? Well, lucky for us for this first one, 7 is a prime number. Since 7 is prime, we're very limited on the number of ways we can multiply to get positive 7. I want you to remember, to multiply to get positive 7, we could multiply positive 1 and positive 7, but we could also multiply negative 1 and negative 7. So if I put positive 1 and positive 7, I would get 1c here, and I would get 7c here. Does this sum give me this sum? Yes, it does. So my answer is c plus 1 times c plus 7. So for this first assignment that we're going to do with factoring, I do need to see that kind of work. I need to see, let me get a pointer. I need to see a list of factors here. I need to see your box. You're welcome to use color if you want, you don't have to, but I need to see that you're understanding that this sum is this sum. And honestly, and you'll witness when I do these notes, you may have to erase some. So none of us are perfect. I'm going to have to erase some. Your paper shouldn't be perfect. I should see some eraser marks. So let's keep going. Question 2. I'm going to make my table. I know I want a squared here. I know I want 64 here. Remember, my answer will come from what goes up here and what goes here. What do I multiply to get a squared? A times a. Definitely multiplies to give me a squared. Now for 64, 64 has several factors, 1 in 64. And you know, honestly, as I think about this, if you make this list of factors, you may not have to do any erasing down here if we just think smartly in just a moment. So 3 will not divide into 64, no. 4 will, 16 times. 5 does not divide evenly into 64. 6 does not divide evenly into 64, and this is where knowing your multiplication facts comes in handy. 7 does not divide evenly, 8 does, 8 times. As I look at this, I know that I want a positive sum and a positive product. So I know I'm going to have a positive and a positive here. So both of these are positive. Because I could have a negative and a negative to give me a positive product. But since I have a positive sum, I just need a positive and a positive. So as I look at those, 1 and 64, 2 and 32, 4 and 16, and 8 and 8, which one of those that I add together will I get 16? Well, that's 8 and 8. So if you have that list over there, you don't necessarily do not have to erase when you're putting into your box. So let's check to make sure. 8 times A is 8A, and A times 8 is also 8A. Then make sure to check, at least mentally. You can circle it if you want. That could be another way to show your work. 8A plus 8A, is that 16A? Yes, it is. So A plus 8 times A plus 8 is the correct answer. Now I want to show you 2 ways you could write that. You're welcome to just write A plus 8 times A plus 8, or you are also welcome to put A plus 8, the quantity squared. Either of these is an acceptable answer to me. Okay, let's look at number 3. I'm going to make my table. I am going to put x squared here and 18 here. I'm going to realize that my answer will be displayed here and here. And I'm going to think about the factors of 18. Again, a positive sum, positive product, so I know both of my factors are positive. 1 times 18, 2 times 9, 3 times 6, 4 does not go, 5 does not, 6 does 3 times. So those are my only factors of 18. And which of those, when I multiply, do I get 11? And I think you all would see that, but I forgot to do this first step. How do I get x squared? How do I get this product? Well, that's x times x. Next, how do I get 18? These are all the ways that I get 18. And we said, or hopefully you noticed, that these are the ones I'm going to use. So I'm going to put at the top, I'm going to put positive 2 and positive 9. 2 times x is 2x. X times 9 is 9x. And yes, 9x plus 2x is 11x. So that gives me my factorization. X plus 9 times x plus 2 is the factored form of x squared plus 11x plus 18, or expressing x squared plus 11x plus 18 as a product. Okay, let me carry on to number 4. Make my table. Put d squared and 8. I will highlight. This is where my answer will be. And let's think about the factors of 8, the things that multiply to give me 8. 1 times 8, 2 times 4, and I think that's it. And next I'm going to talk about, of course, how do I multiply to get d squared? What would go here and here? D times d. And then what would go in this spot? Well, I think we're going to go with 2 and 4, positive 2 and positive 4. The reason why they're both positive is my product is positive and my sum is positive. So I want to multiply to get a positive and add and get a positive. So that makes them both positive. So a positive 2 and a positive 4. Now, 2 times d is 2d. D times 4 is 4d. And so then, when I add these two together, I do get 6d. I now know my answer, my factorization, is d plus 2. And also, as I just thought of this answer is perfectly acceptable. And since multiplication is commutative, this answer is also perfectly acceptable. So either of those is fine. Let's go on to number 5. I need s squared here, 10 here. My answer, again, will be here and here. What do I multiply to get s squared? That would be s and s. And then my factors of 10 are 1 times 10 and 2 times 5. And that's it. And which of those am I going to use? It looks like I'm going to use positive 1 and positive 10. One times s is s. S times 10 is 10s. Is 10s plus 1s 11s? Yes. So my factorization is s plus 1 times s plus 10. That's the answer. Last one for this page that I'm on. I'm going to make my table, put u squared and 9. Then remember, I'm looking for what goes here and here. My answer will be in this highlighted area in just a moment. Okay, and I apologize for all those interruptions. I paused before the announcement went off, but as I look at this, I want to get u squared. U times u will give me u squared. Then my factors of 9, 1 times 9 and 3 times 3, I believe. I think that's it. So I believe I'm going to use 1 times 9, a positive 1, and a positive 9. Let's check and make sure that's correct. So 1 times u is 1u, and u times 9 is 9u. And 9u plus 1u, is that 10u? Yes, it is. So let's write our product, u plus 1 times u plus 9. Let's see what's on the next page. More factoring. And I'm so glad because those first few were just positives. But if you notice now, when you look at these, I've got a positive and a negative and a negative, positive and a negative, so on and so forth. So our factors are going to be a little bit different. We want to multiply to get negative 54. So I'm going to have a positive and a negative factor. We're going to multiply to get negative 2. So positive and a negative factor, positive and a negative factor. Same thing here, here, and here. Okay, so let's just multiply. I'm going to maybe run through these quickly. I think you get the gist of what belongs where, so I don't need to say that over and over. B squared, negative 54. Things that multiply to give me negative 54. I'm going to put two positives, and then we'll talk about where we'll put our signs. Positive 54, things that multiply to give me positive 54. 1 and 54, 2 times 27. I know 3 will divide into 54 because the sum of the digits, 5 plus 4 is 9. 3 will go into 9, so 3 will go into 54. That's 18 times. 4 will not go into 54. 5 will not go into 54. 6 goes into 54 9 times. 7 does not go into 54. 8 does not go into 54, but 9 does. Now let's think about signs. I want a product of negative 54. So that means I'm either going to have negative 1 times positive 54 or 1 times negative 54. If you want to think smart, think about this. I want a positive sum. When you're adding two integers, which integer needs to be positive to get a positive sum? And hopefully in your mind you just said to that answer that the smaller number needs to be negative and the larger number needs to be positive. So we would want to make all of these negatives before we decide which pair to use to satisfy that equation. So as I look at that, I see that if I want to get positive 3, it's going to be negative 6 and 9. So go back to here. My answer is going to be here and here. I apologize for not doing that first. And then b times b gives me b squared minus 6 and plus 9. So let's check to make sure, and do make sure you fill in so you can check. B times b is b squared. Negative 6 times b is negative 6b. b times positive 9 is positive 9b. And when I add these two together, 9b and negative 6b, do I get 3b? Yes, I do. So there's my answer. B minus 6 times b plus 9. Moving on to the next one. Y squared, negative 2, y times y will give me y squared. The only factors to multiply to get 2 are 1 times 2. I want a negative sum. So to get a negative sum, I want to put negative 2 with positive 1. And let's see if that works. Negative 2 and positive 1. Negative 2 times y is negative 2y. Y times 1 is 1y. And then, when I put these two together, negative 2y plus 1y, is that negative y? Yes, it is. So my answer is going to be y plus 1 times y minus 2. Moving on to the next one, I want to multiply two binomials. Get u squared and negative 18. Factors of 18, 1 times 18, 2 times 9, 3 times 6. I want a positive sum, so that means the smaller number needs to be negative. And which of those three pairs gives me positive 3? That would be here. So u times u is u squared, a minus 3, and a positive 6. So I would do my checking here. Negative 3 times u is negative 3u. U times 6 is 6u. Check that mentally. 6u minus 3u, is that positive 3u? Yes, it is. So my answer is u minus 3 times u plus 6. The next one, z squared, negative 56. Factors of 56, 1 times 56, 2 times 28. 5 plus 6 is 11, so 3 will not go into that. 4, I do believe, will go into it 14 times. 5 will not, 6 will not, 7 times 8. Then I want a negative sums. That means my bigger number is going to be negative. And then as I look at these, which one will give me a negative 1 when I put them together? That's those two. So z times z here, a positive 7 and a negative 8. Positive 7 times z, 7z. Z times negative 8, negative 8z. Remember, please check this mentally. Negative 8z plus 7z, is that negative 1z? Yes, it is. So my answer is z plus 7 and z minus 8. The next one, h squared, negative 24. My answer will be here and here. Factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's it. Positive sum, so that means, oh, and a negative product. Positive sum, negative product, that means that I'm going to want the smaller number to be negative. And looking at our list, looks like the bottom one, negative 4 and 6. So a minus 4 and a positive 6. And of course, h times h is h squared. Let's do a quick check. Negative 4 times h, negative 4h. H times 6 is 6h. And when I add these two together, 6h and negative 4h, do I get positive 2h? Yes, I do. So my answer is h minus 4 times h plus 6. Okay, next one. F squared, negative 40, f times f. And then I'm going to write my factors of 40. 1 times 40, 2 times 20, 3 will not go into it, 4 times 10, 5 times 8, I believe that's it. Negative sum, negative product, so the bigger number will be negative. I think it's the last one. A positive 5 and a negative 8. Let's check. Positive 5 times f is 5f. F times negative 8 is negative 8f. And then when I put these two together, negative 8f and positive 5f, do I get negative 3f? Yes, I do. So that is correct. F plus 5, and then f minus 8 is the answer. Okay, what's on the next page? Okay, now it says to solve, which means we're going to combine what we learned in a recent lesson with factoring what we learned today. Now, I do want to point out a couple things. First thing that you have to make sure is that your equation must equal 0. Whoops. Your equation must equal 0 first. After it's equal to 0, you're going to factor like I've been factoring on the previous pages. And then you're going to use the zero product property. And what that means is the zero product property says if you have two factors that are multiplied and that multiplication or that product is equal to 0, then one or both of those factors equals 0. And I'll point that out once we get there. Now I want you to look, 13 through 18. Are all of them equal to 0? No. So for 16, 16 is the first one that's not equal to 0. I'm going to subtract 30 from both sides. I'd have x squared minus x minus 30 equals 0. For 17, I'm going to add 2 to make it equal to 0. R squared minus 3r plus 2 equals 0. For 18, I'm going to subtract 8. T squared minus 7t minus 8 equals 0. Now I'm ready to factor. So for each of these, I'm going to go ahead and draw a rectangle or square. It's probably a square. I don't know. First one looks like a square. These look like rectangles. Leave yourself some space to solve because I'm going to be limited on space down here at the bottom. I may have to do some erasing. Okay. I want g squared and 40, k squared and 6, w squared and 10, x squared and negative 30, r squared and positive 2, and t squared and negative 8. Factors of 40. 1 and 40, 2 and 20, 3, I'll go 4 times 10. I think we did. Factors of 6. 1 times 6, 2 times 3, that's it. Factors of 10. 1 times 10, 2 times 5. Factors of 30. 1 times 30, 2 times 15, 3 times 10. I think that's all. Oh no, 5 times 6. Oops. Silly me. Factors of 2, 1 times 2. Factors of 8, 1 times 8, 2 times 4. That's it. Okay. Now let's look at the signs. Negative sum, positive product. So how do I multiply to get a positive, but I'm going to add those two integers together and get a negative? This is the case where both of these are going to be negative. And then which one do I want? I made a mistake. I had to go delete it. This was an 8. Now, which one do I want? Which pair of integers can I add together and get negative 13? So making this list, I just want to reiterate, making this list here helps to keep you from having to erase to decide what factors go where. Remember G and G, and hopefully you decided negative 5 and negative 8, so minus 5 and minus 8. My product, my factorization will be G minus 5, G minus 8. I can't forget that it equals 0. Then I'm going to now factor, because it says each equation must equal 0. We did that. We said all equations equal to 0. We factored number 13. Now we're going to do the 0 product property. When I look at this, I see two factors. I've got this factor, G minus 5. I also have this factor, G minus 8. According to the 0 product property, one or both of these equal 0, so now you set each of them equal to 0 and solve. Add 5, G equals 5, add 8, G equals 8. So my two solutions, I'm going to try to make space, and I'm going to put them in a solution set. My two solutions are 5 and 8 to that equation. Let's go on to number 14. I want a positive product, so a positive times a positive or a negative times a negative, and I want a negative sum. So how do I get a positive product and a negative sum? Two negatives. And which pair am I going to use? Negative 1 and negative 6, or negative 2 and negative 3? And hopefully you realize it's going to be negative 2 and negative 3 that we're going to use. And of course K and K go here. Now let's check. Oh, I didn't check number 13. Bad example. I'm so sorry. I'm going to go back and do that really quickly. I should have put negative 5G here, negative 8G here. And then of course mentally check negative 5 and negative 8. When I put them together, do I get negative 13? Yes, and I'm not going to make that mistake on number 14. Negative 2 times K is negative 2K. K times negative 3 is negative 3K. Negative 2K plus negative 3K, is that negative 5K? Yes. So I have factored it correctly. K minus 2 times K minus 3. And remember, I'm solving, so I have to set it equal to 0. Now I'm going to use the 0 product property. I have two factors that equal 0. There's my heater acting up, or my unit, whatever that is, heating and cooling unit. I'm going to set each factor equal to 0 and solve. Going to add 2, add 3. So my solutions are 2 and 3. Number 15. I wrote the factors, let me find them. There we go. 1 and 10, 2 and 5. Positive product, negative sum. That means a negative times a negative. And I believe that the majority of you will see quickly which of those we're going to use. We're going to use negative 2 and negative 5. And of course W times W is W squared. Let's check. I'm not going to forget again like I did on number 13. Negative 2 times W, negative 2W. W times negative 5, negative 5W. Put together these two terms, negative 5W and negative 2W is negative 7W. And so I now have my factorization of W minus 2 times W minus 5 equal to 0. I am going to set each factor equal to 0. there's one factor, there's another factor. I'm going to set each factor equal to 0 and solve. W minus 2 equals 0. W minus 5 equals 0. Add 2, W is 2. Add 5, W is 5. So my two answers are 2 and 5. And the order that you put them inside of that solution set really does not matter. So I'm going to erase that. Look like those were connected. Okay. Moving on to the next one. I have a negative product, so one positive, one negative, and a negative sum, so the larger number will be negative. Okay, then I am going to decide which pair of factors to use. I think it's the last pair, positive 5 and negative 6, I believe. My x and my x go here. 5 times x is positive 5x. X times negative 6 is negative 6x. 5x and negative 6x, when I put them together, does give me negative 1x. I'm going to write my factorization and set it equal to 0. I'm going to use the zero product property to solve. We're still using the zero product property in Algebra 2 Honors even now, and it's April. So you will continue to use this throughout mathematics for you once you learn this. So it's very important to master it now. But we'll practice in class, so I believe you'll master it. There's the answer to number 16. Number 17, I have a positive product and a negative sum, so both of these are going to be negative. A negative 1 and a negative 2. So sorry, that's running together. Try to make it separate. Okay. And then, of course, R times R. I'll have R minus 1 times R minus 2 equals 0. I'll do the zero product property. I have to do them on top of one another there. I'm going to add 1. R would equal positive 1. I'm going to add 2. R will equal positive 2. So my two solutions are positive 1 and positive 2. And that is a comma between them. Looks like a decimal. Always put a comma between your solutions. So there's the solutions for 17. I believe this is the last one, number 18. I'm going to put my t's first, t and t. Negative product, negative sum, so larger number is negative. Which of those two would give me a negative 7 when I add them together, and that's the top one, a minus 8 and a plus 1. Let's do some checking. Negative 8 times t is negative 8t. T times 1 is 1t, and then is negative 8t plus 1t equivalent to negative 7t. It is. I'm going to put together my product, t minus 8, t plus 1, set them equal to 0, do the zero product property. I do expect to see this step. I think I just remembered we're not finished. There's one more problem. And so t will equal 8, t p will equal -1. So my two solutions are -1 and 8. And the order really doesn't matter. I just usually put them in order from smallest to largest, but it does not matter what order in which you put those solutions. Let's see, I think there is one more example. Yes, there is. And actually two more examples. Word problems. We all love them, don't we? The area of a right triangle is 16 square units. Let's draw a right triangle. The area is 16 square units. One leg of the triangle is 4 miles longer than the other leg. So if this leg is x, this leg is x plus 4. And I did not read the miles. It says miles. I'm going to erase that and put miles. Oops. Okay. MI, I think, is the abbreviation for miles, isn't it? Okay. Find the length of each leg. Now remember, the formula for area of a triangle, we just discussed this in class the other day, is 1/2 times base times height. Let's fill in what we know. Do we know the area? Yes, it's 16. Keep your 1/2. Do you know the base? Yes, it's x. Do you know the height? Yes, it's x plus 4. Now, what I want to do that will make life easier for me is I want to multiply both sides by 2 to get rid of that fraction. So anytime you have a fraction, you can multiply by the denominator, and that just eliminates the fraction on the right-hand side there. So I'll have 32 equals x times x plus 4. Next, I'm going to distribute 32 equals x squared plus 4x. I have a quadratic to the second power. I'm going to solve this quadratic. I'm going to subtract 32 from both sides because remember, to solve it has to equal 0. I'm going to write it up here. I'm going to use the symmetric property of equality. I'm going to swap that 0 and put it on the right-hand side. That's just what we're used to. So x squared plus 4x minus 32 equals 0. I'm going to factor using a chart. For now, that's all we know, so that's the work we're going to show. I know I'm going to put x squared here, and I'm going to put negative 32 here. Factors of 32. 1 times 32, 2 times 16, 3 does not divide evenly into it, 4 times 8, 5 does not, 6 does not, 7, 8, so that's it. I want a negative product, positive sum, so the lower number, smaller number, will be negative. And it looks like it's the last one. I'll have a minus 4 and a plus 8. Let's check and make sure. X times x is x squared. Negative 4 times x is negative 4x. X times positive 8 is positive 8x. Mentally check 8x and negative 4x. When you put them together, do you get positive 4x? Yes, you do. Now I'm going to put that product there. X minus 4 times x plus 8 equals 0. Do the 0 product property. X minus 4 equals 0. X plus 8 equals 0. Solve. Oops. So x equals 4. X equals negative 8. Now we have to think about what x stands for. X is the measure of the smallest leg of this right triangle. one of those solutions we have to throw out. Think about which one. Which one is impossible to have as the measure of a leg? And that's x equals -8. So I know that my smallest leg is 4 miles. And how do I find the bigger leg? I take 4 miles plus 4 more is 8 miles, and that's the largest leg. And that's what it asked me for. It asked me for the length of each leg. So 4 miles is one leg, 8 miles is the other leg. Now we are looking at number 20. You have 2 circular flower beds as shown. The sum of the areas of the flower beds is 136 pi square feet. Find the radius of each bed. So the formula for area of a circle, this is another one of those formulas that I think you should remember, and that's pi r squared. For both of these, we know the radius. The radius is r for the larger circle and r minus 4 for the smaller circle. So it says you have 2 circular flower beds, the sum of the areas. So small circle area plus large circle area equals total area. Okay, let's fill in what we know. Small circle area. Area equals pi r squared. So pi times r minus 4 squared. That's the small circle. Large circle area. Pi r squared, because r is r, equals the total area is 136 pi. Now let's expand, that's what that's called, or calculate this answer. So pi times, I have 2 of them. I'm going to bring the rest down. Pi times r minus 4, minus 4 times r minus 4. Bring the rest of that down. Okay, so r squared, I'm just going to write this right above it because my space is so limited. R squared minus 4r plus 16. So I'm going to have r squared minus 8r plus 16 times pi plus, I'm going to put r squared times pi, and that equals 136 pi. Can you see, and I hope you can, this is such a strange problem, can you see that each of these terms contain a pi? I hope you can see that. So I can rewrite it, since they all contain a pi, I can rewrite it to look like this. R squared minus 8r plus 16 plus r squared equals 136. I'm going to combine like terms, and I'm going to move the 136 to the left side. 2r squared minus 8r plus 16 minus 136 equals 0. Then I'm going to put those two together. 2r squared minus 8r minus 120 equals 0. Do you see? I hope you do. This one is really tough, so if you're totally lost while we're doing this, I understand. Or if you know when I'm finished you would not be able to do one by yourself, I understand that. But as long as you understand as I ask each question, that's what's important. But do you see that I could divide by 2, and I only do this because I'm solving. I could divide by 2 because they all have a common factor of 2. I would have r squared minus 4r minus 60 equals 0. And then I'm going to make my little box over here. R squared and negative 60. This will be r and r. We'll make the factors of 60 over here. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, 7 does not go, 8 does not go, 9, so I think that's it. And then I want a negative product and a negative sum. So my largest one is going to be negative. That would be this one, right? Negative 10 and positive 6 will give me negative 4. Yes. Negative 10 and positive 6. And let's check that. Negative 10 times r is negative 10r. R times 6 is 6r. Negative 10r and 6r, does that give me negative 4r? Yes, it does. I'm going to put them together. Then I'm going to do the zero product property. Add 10. So r is positive 10. Subtract 6. R is negative 6. Now, which one of those, and I'm sorry, it's hard to see that negative, which one of those should I toss out since I'm talking about the radius of a flower bed? That would be this negative 6. So R, the bigger radius, is 10. Where am I going to put that? Maybe I can put it right down here at the very bottom. So big circle, big flower bed. Radius 10 feet. And then the smaller one, 10 minus 4, smaller, radius 6 feet. I'm going to highlight my answer here so you can see. So the big flower bed's radius is 10 feet. The smaller flower bed's radius is 6 feet. And that's my answer. I think that's it. I apologize for it being so long, but this is such an important skill that I knew this would be a long video. Okay, so let's look and see if we're finished. Yes, we are. There's your assignment for the week. And of course, we'll start that in class so that I can help you. I hope you have a wonderful day.